This video is to present how to write a linear equation representing a straight line from a typical economics graph. Okay. And so what we're going to be doing now is a little bit different from the normal way to write a linear equation. So normally we write y equals mx plus c, or some books will have ax plus b. Important thing here is that normally the vertical axis, the y-axis, is on the left side. I'm going to circle it actually in purpose. All the numbers here, this number line represents a variable that we call y, or usually what we call the dependent variable. And over here in orange, it's the x-axis. This is a number line, a horizontal number line. And what we do is we pick a point. I'm doing this a little in reverse. And if I take a line and just drop it straight down to the x-axis, it tells me what we call the x-coordinate. And so I write that point here in the form what we call xy with brackets around it. And if I want to know what the y-coordinate or the value of the y variable is, I would go straight across to the y-axis, and I see the number 11. So that would mean that the what we call the y-coordinate would be 11. All right, so if I want to tell anybody where a point is, I can actually just drop my drop a line as if I'm dropping a rope down to the ground to the x-axis and read that off. Or if I was literally holding my hand out at the right angle, then I could just go across the y-axis. And similarly, of course, I can place points on this. And so I'm going to place a point here now, and I'm at the x-axis. So whenever we are on the x-axis, the y variable, we're going to go across here now. That's 0. We're on the y-axis, and literally dropping this down, it's x equals 0. So now I'm going to kind of adapt this for economics. So in economics, we normally put in our typical graph, our model of demand and supply, we put quantity on the horizontal axis, and we put price on the vertical axis. And when I do that, there's a little bit of modification that I have to make to my usual y equals mx plus c. So in the y equals mx plus c format, the c is what we call the y-intercept. It's when x is equal to 0, this part disappears. And so this part is going to be on the y-axis, and so it's called the y-intercept. So if I put this here, then I would know that the point, the y value when x is equal to 0 is 15, and my y-intercept would be 15. But in economics, somebody decided to do things a little bit differently, so I'm gonna cross that out a little. What's the difference? The difference is that the dependent variable, the variable that's going to be dependent on something else, is q, and I'm going to talk about demand first. Quantity demanded is a function of price, right? So people will buy, quantity demanded is the amount that people are willing and able to buy at each and every price. And so I am going to create a linear demand function, and then I'm going to say what the constant is. Okay. So linear demand function. So I'm literally, let me just drop this, drop it in a particular way here, right? And so that's a line. I have a linear demand. So I'm going to have it, it's going to take the form QD equals some number, I'm gonna call the constant here, and that's not going to be multiplying by x, plus call the slope, the number that's gonna be multiplied by x, and we'll get back to that. All right. But it's a little bit reversed. Instead of being on the vertical axis, quantity demanded is on the horizontal axis. And so what's the constant in that case? In that case, it's where, so let me put the slope times x here. It's what happens when, not x rather, price. What happens when price is equal to 0? Well, this is our price axis, price equal to 0 here. Well, where's the x? It's here, 30, right? And so quantity demanded is equal to 30. So what does the slope tell us? The slope tells us if price increases by $1, how is Q going to change? So what I'm going to do, I'm going to increase my price by $1. I'm going to go over here. What happened to? So what has happened to? I can see my quantity decreased by 2 units. So my quantity demanded is equal to 30 plus, or I shouldn't say plus, add it. It's the, what is the change when I increase the price? I have a decrease. So my slope is 2 times the price. So again, the slope, or the number that multiplies the price, tells me if I increase price by $1, how much will quantity demand decrease?